No, I did not yet, did I? Whoops. I was supposed to. It's this giant stack. So I can give you the generally but because degrees of representation information on sample size, then you're going to present it in either way. But I'll mention. So there's never going to be a question. The advantage, did I give you guys? The advantage to degrees of freedom over sample size. Degrees of freedom just makes it a little bit more clear what value of n becomes 1. So for instance, if we're looking at like n minus 2, where the degrees of freedom have to be 1 to 1, it makes it very, very clear that having a sample of only 2 data points or only 1 data point, or that's not even like one value.
No.
Whereas if we just let the table have to n, yeah, we can cap the table off at like 3, but it doesn't communicate like why. But 3 and even the degrees of freedom, they're the same.
It's not out yet.
It'll be like clear, like this is degrees of freedom. Moment.
I still need to take this quiz.
Okay, would you be able to say after today?
Not today.
Okay, would you be able to come in early tomorrow? Like in another period? If not, that's fine, we can just have you do it already, like tomorrow, during the whatever else you think that's. Okay.
What did I do?
Okay. Let us. I'll translate well in the recording. So unit 1 was a lot of, oh, sorry guys. Did I not? You know? Just leaving my out. It's good. As I intended, of course. So we're going to move on. We're going to start Unit 2. We're going to find Unit 2 is pretty vocab intensive, especially kind of at the front end here. Unit 1 was our attempt to take in something that we had already done, linear regression, which a process that we had seen before, and kind of piece to it this statistics-specific kind of verbiage that we see. In particular, we saw, especially with 1.3, that we were taking in that kind of same linear regression stuff that we had done up until now, and we can talk about it a little bit more robustly when we add this idea of like the alpha values and the hypothesis testing and things like that. It gives us the sense of before, okay, maybe an R value is strong, but now we know to be able to say, is the R value strong, or is it strong enough? Is it like too weak? Things like that for our purposes. Unit 2 is going to be a little bit more of an overview into statistics. So rather than kind of hyper focusing on one kind of little subsect of stuff that we had hopefully already done. We are instead going to be taking a look a little bit more broadly at like what is statistics? What are we talking about when we are referring to statistics? I defined this a little bit on day one of like what a statistics class is trying to communicate and why the statistics is kind of a valuable set of metrics, but we're going to go back over that again here. In terms of just kind of our like most basic definitions, statistics are, for all intents and purposes, just a set of tools that we are going to use to say something about data, or maybe a better way to say that, they're going to be tools for analyzing data. Most of the statistics that we have seen up until this point have been, we'll see this definition here in a moment, what's called inferential statistics, where we are analyzing data with the hopes to make some kind of prediction about the future or some kind of prediction about the past. That does not necessarily need to be the case, and we'll look at a whole variety of statistical measures where that is not the case. But certainly to start out, that was kind of what he's okay. Here. Yeah. All right. So these are going to be our tools. What follows here is like this little blurb of like, you know, oh, the answer to the question of like, when am I ever going to use this? Statistics is one of the two classes that I would say you can't really get away with asking that question of like, when is this going to be pertinent in my life? Thanks. And that's for a variety of reasons. One reason is that it is frighteningly wide-reaching. A really, really great kind of example, and I think an example that highlights the fact that a lot of us are, to a fairly large degree, pretty statistically literate already, is the idea that we use kind of our interpretations of data and that ability to make predictions from that data with a very, very shocking amount of regularity. A great example is the statistics that goes behind a lot of sports analysis. For instance, if we're talking about RBI and what we would expect to see from a batter who has a lower RBI versus a higher RBI, or if we were taking a look at free throw percentage, what we would expect to see from a basketball player who has a lower free throw percentage or a higher free throw percentage. Things of that nature. That's kind of the language that we talk about a lot of kind of competition, what we talk a lot about kind of our using for our projections. Of course, you know, sports analytics kind of carries that nature in and of itself. But this is also incredibly wide-reaching in pretty much any field that you can go into. A really cool example that I think is not that surprising when you actually kind of start going through a lot of the kind of academia that you would need to for this kind of thing. I have a friend who is currently working in a psychology study. And in college, she had a project. This is like her like honors thesis, where she really, really tried to overlap her two degrees. She had a music major and a psychology major, and she was trying to really kind of marry the two with this thesis, during which she went around and analyzed the effects of playing various music or types of music, playing various types of music to people while they slept, and analyzing how good their sleep was as a result, maybe not as a result, but in kind of correlation to the music that was playing. And this is, again, like this is psychology, which is not to insult psychology, great love for psychology, but a soft science. This is music, which again feels like should have very little connection to math until you actually take up some higher level music classes, and then you're doing nothing but math. And the sole kind of math that she was required to use was statistical analysis, right? So this is something, it is incredibly wide reaching, but I think there's more to statistical literacy than a simple, oh, I will use directly the things that I have learned for this class in my job. And this is maybe a little bit of a cynical take on reality, but I do think that there is enough kind of evidence of this that it is not so overly cynical. And that is that there are people in this world who have pieces of paper that tell us that they are better than us at math. That's me included. And these people are more than capable of doing statistics well, of doing statistics properly, of correctly making conclusions from the data that they are receiving, correctly interpreting results, things of that nature. But they are also capable of getting convincing looking results and intentionally misinterpreting what the data is trying to say. There is a lot of subterfuge in trying to navigate what people are saying is true about data, and that is generally the result of not, I don't think, understandable mistake, but I do think that there is a slight degree of malicious intent behind it. And so being statistically literate, understanding the difference between correlation and causation, understanding that like what confidence means, understanding what sample size does to a statistical measure is incredibly, incredibly important for being able to navigate the world, which is full of statistics, which is full of people who are either inadvertently or deliberately misconstruing data in a way that benefits them. A lot of the terms that we're going to be looking at are fairly, I'd say, straightforward, kind of like common sense. But again, we're going to put definitions to these. As far as our variables, when we're looking at values, they're either constants or they are variables. Variables are the ones that vary, go figure. So we might say about this. These are maybe objects that can take on a variety of values. All right. Objects here is used fairly loosely, but all this is trying to say variables. If we were looking at like an assortment of M&Ms, a variable could be the fact that there are some red M&Ms and some green M&Ms and some blue M&Ms and whatever. Something that would be constant would maybe be the fact that they all have M in the middle of them. All right, so variable is just a thing, an aspect of a thing that can be changed. And there are a variety of variables and things like that. Data, which again, we kind of have a pretty intuitive understanding of what we're talking about when we talk about data. But again, these are essentially the variables that we are going to be studying, or maybe the measurements on a particular variable. I think that's a pretty good way to define it. So measurements of a particular variable, which is just to say I looked at this particular data point, and for this particular M&M that I drew, it was red. Right? That is a kind of example of a data point, a single kind of piece of the data, which is saying that this variable has taken on a particular value under this particular observation. A data set, very simply, is just the collection of all the data. Right, so that would be me sorting through 50 M&Ms and saying that 17 of them are green and 13 of them are blue and 15 of them are red and 5 of them are brown and none of them are yellow. Things like that. And collectively, that would all be my data set. But our understanding of like what this is trying to refer to is generally speaking good enough. Now, as far as our usage goes, so far we have really been focusing on using statistics to make predictions. This would be like using our linear regression to say what's happening at a particular value of X, or what it's going to match to a particular value of Y, things of that nature. It is not the only way to use statistics. It's probably the most fun way to use statistics. It's probably the most relevant way to use statistics. But certainly the statistical measures that we take stand for themselves. An RBI of 0.3 is possible to be used to make an inference on what this person's performance is going to be when they come up to bat. But beyond that is already saying something about every other time they have come up to bat. When we are using the statistical kind of piece, not to make a prediction about the future or not to generalize to a broader population, but instead just to describe the data as we see it, we are using what is called descriptive statistics. This is going to feel fairly redundant, but these are statistics that describe the data set, and importantly, they are not making predictions beyond what we see with the data set, or not trying to make generalizations. Predictions is I think, an okay way to describe. So for instance, let's consider this table that we are given, where we are trying to look at certain growth rates, and we're actually not really doing anything with that information. So you'll notice here we are given the year, we are given the population, we are given the growth rate as a percentage. In this case, the statistical measure that we are considering is the growth rate, the percentage of growth that we see. But the table isn't trying to do anything with that growth rate. We're not trying to make any kind of guess as to what's going on in 2020. We're not trying to make a guess as to what went on in 1980. We're not trying to make a guess as to what's going on in 2005. We are simply stating that for this particular data sample that we have collected, we see this percentage growth, which is slightly meaningless because growth rate, whatever, it doesn't matter. The point here being, we're not trying to use these statistics to make any claims beyond just this describes the data that I have already collected. A great example of that would be if I were to go around this classroom and count the number of people who are wearing sweatshirts and to generate a percentage of people who are wearing sweatshirts. Not doing anything with that data. This is simply a way to say something about the data that I have collected, right? That a fraction, that some percentage of people in this particular classroom are wearing sweatshirts. How we are going to mostly be using statistics, this is the more fun aspect of statistics and kind of what we've really been doing for the most part, is with what we described earlier as inferential statistics. So descriptive statistics are just saying this is the average, this is the growth rate given this data, this is the percentage of people who are wearing sweatshirts in this particular classroom. Inferential statistics is then using that information to try and make predictions about what will happen in the future, or to take that claim that we are making about a particular population and apply it to a broader population. So these are statistics that attempt to generalize or predict outcomes. From the data. All right. Example given, again, based on the data that we saw before, we now have predictions for what would be going on in 2020, although actually we have that information. What would be going on in 2040, what would be going on in 2060. These are not points that we have measured. Right? This isn't part of our data set. We haven't collected anything that tells us, well, we have for 2020. We haven't collected anything that's saying what goes on in 2040. We don't know what's going on in 2060. We are using the information from our data set to infer, to guess what's going to happen in the future. And if we do it in the right way, then hopefully we're relatively close. Again, with the sweatshirt example, we could take that information, the number of people in this classroom who are wearing sweatshirts, and maybe we could try and broaden the target demographic. Maybe rather than caring about the percentage of people in this particular classroom who are wearing sweatshirts, I instead want to make a claim about what the average Collierville High School student is going to be wearing. So I am either generalizing or I am making a prediction. If I take a random student, what will they be wearing? What is the percentage chance that they will be wearing a sweatshirt? And that would be using the statistic that I had before to make an inference about something beyond just what was measured precisely. And notice that when I'm doing that, I'm not all of a sudden going around to every single person counting up the number of sweatshirts. I could do that, but I'm not. I am instead saying, based on what I have seen in this smaller subset, I would make these kinds of predictions about my larger demographic. I think of import here, like a really kind of cool thing that this highlights, is that a statistic is not in a vacuum descriptive or inferential. Percentage of people in this room who are wearing sweatshirts can either be used as a descriptor, it can be used to describe what the people in this room are wearing, or it could be used inferentially to make a claim about what we would expect to see from all of CHS. Right? So it's the context here that's really, really important. The statistic itself can be used in either kind of way, and you have to be paying attention. Is this being used descriptively? Are we just talking about the data that we have collected, or are we trying to make a claim beyond just the data that we have collected? Again, fantastic example from what we were doing in chapter 1. The linear regression equation that we found, the y equals ax plus b, can be a descriptive statistic of the data that we have collected. But we then used that descriptive statistic to make predictions outside of what we observed directly from the data. Again, it can kind of be either it's context dependent, really, really heavily context dependent. And oftentimes the context is actually pretty easy to pin down. And it comes to a difference between, is the statistic that we're using describing a population, or is it describing just a piece of a larger population that we want to talk about? Notice that whenever I shift to talking about this inferential statistic, I'm broadening my horizons. I don't want to talk about what's going on in just this class. Now I want to talk about what's going on in all of CHS, or I want to talk about what's going on in every high school across the country, or every high school across the world, what have you. So population, for our intents and purposes, this is going to be all subjects being studied or observed or what have you. And a sample from this population is going to be a subset of the larger population. So we're saying we're taking maybe a population of, I don't know, like 3,000 individuals, and we are looking at 20 of them. And the idea is that looking at that 20 might be able to, if we've done this correctly, tell us something about what's going on with the larger population. All right. Pause here before we move on. Any questions about our definition so far? Okay, so let's take a look at this example here. And let's actually put this into the context of what I'm trying to do. I'm trying to figure out, if I pick a random person, how likely is that person to be wearing a sweatshirt? Like find a percentage chance of picking a random person and that person be wearing a sweatshirt. I have two options. I can either poll what's going on in this classroom and use that to try and make some kind of inference, or I could go to every single student around the building, figure out if they are wearing a sweatshirt, and then have a descriptive statistic that says definitively this many people out of my total population are wearing a sweatshirt. What are the merits to each approach before we are packing up? I guess we've got like a minute and a half. So why would it be good to do a sampling? Why would it maybe be good to take a look at the broader population? A sample is easier. I think that is a really, really, really good point, which is that a sample is convenient. Going around, before we are finished, to every single CHS student and looking at whether they're wearing a sweatshirt or not is hard. It takes a lot of time. Imagine if I was doing it for every single high school student in the nation. It would be very, very difficult. What would the advantage of my doing that be? It might be more accurate. It would be more reflective. Population descriptor.
And you couldn't just hypothetically take a survey, be like, did you wear a sweatshirt today?
Well, you could, and then you might have bias for the, did they lie, did they tell the truth, and then you get into all sorts of really fun stuff. Did the descriptor might be more accurate. And I think that's kind of the play that we will see here, is we have convenience versus accuracy, although what we will see is that that is in fact not always the case.
Yeah.
All right, have a fantastic rest of your day. Don't forget classworks, don't forget homework. Let me know if you have any questions. It might be.
When did the food station?
So I will be here. I'm basically here after school
Well, it
Tuesday
doesn't
through
cost
Friday.
anything, right?
No. This is just I'm here. I'm answering questions.
I
I'm
want to be
happy to
able
work.
to know so I can know what we it exactly.
Yeah. So my standard tutoring time is Tuesdays until 3:45, but I will also be here after school for clubs, Wednesdays, Thursdays, and Fridays. So if you have
Wednesday,
any
Thursday,
questions
Friday?
until it's like 4 on Wednesdays and Fridays, and it's till 4:30 on Thursdays. So if you have any questions, I'm basically going to be here after school, and you're more than welcome to. But my official tutoring times are Tuesdays until 3:45. Yep. And if you have any questions and you're not able to come into tutoring, you are always welcome to send me an email, and I'd be more than happy to take a look. Yeah. Sounds good.